Hey everyone that's joined, appreciate it. I think it looks like we got a few people trickling in right now, so you might hear me just repeat myself very quickly. Okay, I think we're good to go here. If anyone has any audio issues or can't see the slides, just shoot a message in the Q&A section. If you actually click on that Q&A section, you'll be able to type in, oh, Christian, I think you got a little feedback there. There we go. Okay. And if you have any questions throughout the presentation, just type them in that Q&A section, and we'll go over them at the end. I just wanted to thank 10 Power for helping set this up, bringing in some participants, and a big thank you to Christian. Christian, really appreciate you being here. And if you want to jump in and just say anything before we get started.
Excellent. Good morning, everyone. Thank you, Troy. Happy to be here. So my name is Christian Tribute, representing 10 Power as a sales engineer, and I'm based in Port-au-Prince, Haiti. So for anybody here in Haiti, we'll be here to be able to give you direct support. Thank you very much.
Awesome. Thank you, Christian. All right. And Christian will be helping with questions at the end as well. So feel free to let him know. If it's in French as well, that's okay, and he can answer those. All right, let's jump right in. I'm going to do a little differently today. I've got a lot of tools on our website that we're going to actually jump out of the presentation for and just kind of go over them. So we'll try to go as quick as we can here so we have enough time. Okay, quick little overview about SimpliPhi Power. 2010, founded as OES Energy. This is the original name of SimpliPhi Power, really just kind of starting to work with lithium batteries. At the time, we're talking lead acid is king, and really this is the kind of introduction into lithium realm. 2011, 2012, residential, military, and emergency response projects kind of let us build up our company base, keep expanding on various technologies. 2013 to 14, we actually added some products onto our line where we were able to do all-in-one products and a bit more diverse range of products. Then 2015 to 2016, we actually relaunched as SimpliPhi Power and continued to build the new products, even like the more all-in-ones, and kind of refine our manufacturing. 2017 till about now, we just continue to ramp up our manufacturing, refine our products as we can, and try to stay on the curve. Kind of our motto here is we have safe, proven, simple technology. Safe as it's non-toxic, non-hazardous, cobalt-free chemistry, all UL certified, proven, and I'll save that for the next slide, which actually goes into a little bit more in depth of exactly where we're at. And simple. We always try to keep it simple. We started this company as a easy lead acid replacement. We've moved on since then to do numerous other things, but that's still something we hold kind of close to us as a simple solution for that, making all of our products as easy as possible. Okay, so this is actually where we're at right now as far as our reach. And this is always growing. Where we're at is always growing. 100 plus megawatt hours since 2010. I can't ever keep up on this slide. It's always changing and always growing. All right, so let's talk a little bit about battery chemistry to get started. Oftentimes when you hear the word lithium ion, I think there's a stigma around it, where we're talking about dangerous batteries. And really lithium ion refers to the entire encompass of lithium chemistries. So within that, there's various different types of lithium chemistries. Some of them might be NMC. This is a really common one you might heard of, like LG and Tesla Powerwall, typically NMC batteries. There's some other ones that you might see on laptops, things like that. And then there's lithium iron phosphate. So lithium iron phosphate differs from the other lithium ion chemistries as it is not prone to thermal runaway, non-toxic, and because of this, it doesn't require ancillary cooling equipment, ventilation requirements, and can actually withstand some pretty high temperatures, even in operation. So after a company's decided on what chemistry they're going to use, we still need to pick a form factor to house that chemistry. On the right here is kind of 3 really common form factors you're going to see. The cylindrical cell, think AA battery. I mean, that's as simple as it gets. It's really the tried and true form factor to house battery chemistry. The pouch cell, this is probably something you would see in your laptop, your cell phone, your tablet, and prismatic cells. So these are not really used as much anymore. I don't see a lot of them, but they are they're definitely a big blocky cell that can hold the chemistry as well. So currently what we use is a lithium iron phosphate. It's either LFP, or you could say LiFePO 4, or with a cylindrical form factor. This is kind of the basis of all of our batteries and all of our products. We've tested basically all of these chemistries. We've tested most form factors as well with these chemistries, and we find that the lithium iron phosphate is the longest lasting, safest, and really shines the best when it comes to using it with a cylindrical form factor. Okay, as far as warranty goes, warranty's actually changed a little bit recently. So it now is 10 years unlimited cycles. Regardless of depth of discharge, you can actually use the battery up to 100% DOD, discharging the entire capacity. So again, 10 years unlimited cycles. There's definitely a reason that you might want to use 80% to prolong the battery's lifespan beyond the 10-year warranty period. But, you know, if you have a situation where maybe it's backup or something like that, you know, 100%, you're going to get that 10-year warranty still. End of life, or EOL, is something that's pretty common in battery warranties. This is referring to what you should expect to see at the end of its warranty period as far as remaining life, remaining capacity, or usable capacity. So we say 80%. So basically 80% of the battery's original capacity is going to still be there at the 10-year period. As far as temperatures go, don't really worry too much about operating temperature. That means discharge or standby. We're talking -4 degrees to 140 degrees Fahrenheit. The really important one is charging temperature. Most batteries need to charge, so this is about where we stand, 32 degrees Fahrenheit to 120 degrees Fahrenheit, or 0 degrees Celsius to 49 degrees Celsius. So really on the high end of things, this eliminates the need for coolant, liquid coolant, HVAC, or ventilation. Okay, each of our batteries come with an integrated battery management system, BMS. Really its function is kind of not something I would rely upon. You still need to program the system, which we'll talk about later, but it does have some level of protection for overcurrent protection, short circuit protection, charge and discharge protection. It also performs cell balancing. This is passive cell balancing, meaning we're bleeding off resistance on the high end of things. This keeps the battery nice, even, as well as in balance with the other batteries within the system. As far as power rating goes, we actually rate all of our batteries at C/2. So those that don't know, a C rate is just a measure of the rate at which a battery is discharged relative to its maximum capacity. So we do rate all of our batteries at C/2. We also allow our max continuous discharge, max continuous. So not max discharge, we actually allow a little bit more as far as surge goes. But as far as max continuous, for any of our 48-volt battery line, it is C/2. So you can discharge basically half the battery's total capacity in 1 hour, and you could do that for 2 hours. That's the maximum continuous. Most residential cases or lead acid replacements, probably not even going to be something you're going to consider. You're not even getting close to that maximum continuous discharge. Little note here, the 24-volt batteries actually are less than C over 2. So definitely check out the spec sheets when looking, if you're doing a 24-volt installation, it is going to be a little bit less than C over 2. So keep that in mind. But this can definitely help when it comes to giving us a smaller battery bank that can cover significant loads, things like air conditioners, pumps, things like that. Definitely as far as the 48-volt batteries go that we offer, it can handle quite a bit of power. Our batteries are scalable and expandable. So as far as scalability goes, there really is no limit to how many of our batteries can be put into parallel. They are parallel only, so meaning that you do not take two 24-volt batteries and put them in series to create a 48-volt. You just buy the 48-volt block, and then you can parallel those out. There is virtually no limit. We have the system here on the left, 88 batteries in parallel, 300 kilowatt hours, working great. We also offer expandability, meaning that we can go and actually add batteries after a system's already been put in place. So this can really be useful if you're maybe sizing a lead acid replacement, or even if you're just building out a new system, maybe energy demands grow, power demands grow, whatever it may be, you can always come back within this 3-year period and actually put in new batteries to an older system. And it's true with most lithium batteries. Our chemistry is stable, self-contained, no maintenance, doesn't need, doesn't off gas, doesn't need any venting, doesn't need any watering, specific gravity checks, anything like that. The battery is essentially maintenance free. It also has a very low self-discharge rate. It's actually less than 1% per month, meaning if the battery is just sitting somewhere, or if it's just in a state of standby, it's not just going to lose power idly. Okay. I want to go through our product line, and then we're going to jump into some cost stuff and some lead acid replacement. These are really the main batteries, as far as the main products, I should say, as far as what we sell. The 2.9 kilowatt hour comes in 24 and 48 volt, and the 3.8 comes in 24 and 48 volt. These are simple, modular, scalable units. They're designed to be small building blocks, easy to work with, that you can scale up to fit any energy or power need. They all come with battery management systems, integrated circuit breakers, and really, again, as far as scalability goes, there is no limit. We also offer all-in-one units. We have an access unit here. The access unit is an all-in-one unit with batteries, inverter charger, in an NEMA 3R enclosure, so outdoor rated, and comes in different varieties here. So let's talk a little bit about what those varieties are. So we actually have the access with Schneider. Comes with the 6.8 kilowatts inverter. Actually, now it comes with the XW Pro. This one comes AC coupled standard, and you can always add in a charge controller to go DC coupled. Just a quick note, something we're finding, if you're looking to do things like time of use or peak load shaving, AC coupled is not the way to go, or at least not with this unit. We want to make sure that we're going DC coupled if we're trying to get that functionality out of these. We also offer it with the Solarc 12K and 8 kW. This one is AC coupled or DC coupled right out of the box. The MPPT charge controller is actually built into it. This can do some cool features. Again, I wouldn't use AC coupled if you're going to go for things like TOU, but if you are going for backup or retrofit, it makes a lot of sense there. All these units actually have built-in automatic transfer switch, so an ATS isn't required on the external between the grid and the unit. So basically, if the grid goes down, this unit goes into island mode. Now you can, if you're AC coupled, bring back online your PV array, charge the batteries, discharge to your home, or if you're DC coupled, basically it's seamless crossover as well, and you're still able to charge, cover loads, and use the battery. You can add things like generators onto these through the other AC ports, and they each come with their own monitoring, which we'll go into right now. So Schneider monitoring is just the Schneider system, the CommBox. I think it's now the WebBox. We're just talking about, historical data here on top. You can actually manipulate this data to show exactly how you want to see it or how the customer might want to see it, as well as real-time data below here, which, again, these are kind of cool monitoring platforms that we're just utilizing already that actually are able to be on your cell phone, your tablet, whatever it may be. It can be pretty good for the customer as well as the installer. SolarX monitoring, really, we're talking almost the exact same thing here, just a bit of a different face on it. But again, real-time monitoring, historical monitoring. The big difference, though, is this one is able to be wirelessly programmed. So you could be sitting in your home and mess with the settings, which can be helpful as an installer. Okay, some other products we offer. These are kind of our smaller emergency power or mobile products. The little Jenny and the big Jenny. You can even get it with the foldable solar kit. Still utilizing LFP, still utilizing the same manufacturing process, but these are really for kind of small electrical needs, nothing like an AC unit or anything like that. But they're great for bringing on site. Maybe a clinic or something like that might just need a few lights or something like that might be a good use for this. If you're looking for a little bit more power as far as mobile applications go, we also offer the Express unit. This is a NEMA 3R enclosure, so it is outdoor rated. It actually is designed to be easy and quick connected. So we have a DC quick connect inlet. This is actually used to plug in PV, charge the batteries, and then quickly disconnect PV to bring on site. There's an AC inlet. This would be charging from the grid, 4 outlets for pulling power directly from the unit, and 2 USB ports for also pulling power from the unit with anything that's powered over USB. These units are really cool. We can actually hardwire into these units and utilize the inverter and the charge controller. But, if you don't want to do any hardwiring, this unit can be charged up straight from the grid, stored away, low self-discharge rate, so you expect that energy to still be in that battery, and then pull power when you need it, when the power is out, or bring on site to wherever you may be using it. I won't go too much into this. These are online. Just an idea of what you might be able to run with these units. Even things like 6,000 BTU air conditioning you can see here for a number of hours. But this if you ever want to look through this, get an idea of what you're using, how many hours, and kind of calculate out the runtime. Okay, the last product I'm going to talk about before we hop into some other stuff here is our high voltage solution, a bit of a newer product, still utilizing the smaller 3.2 modules actually. So each of these little blocks here is 3.2 kilowatt hours. And you can actually get these in 24 or 48 volt. From there, you can scale up this unit. So you have about 200 to 800 VDC nominal is what these stacks can be built into. And then you can parallel those units once they're stacked up in voltage to about 2 megawatt hours of storage. This is for things like microgrids, large-scale backup. If your AC power is a 480 volt 3-phase need, this might make a lot of sense. The BMS is actually external. It actually comes with CAN bus, Modbus, and Ethernet communications built into it, as well as its own internal monitoring system for the battery. So this is the current BMS, the Nuvation BMS. This is specifically what we use for the external BMS, as well as you can see here where we connect into each battery module. Okay, so again, and just one more point here, you know, containerized solution-wise, I'm not sure exactly where we're at. Maybe I know Jesse's on the call. Maybe I'll let him answer that later over the Q&A. But I believe for a little while there, we were offering to containerize the solution and ship on site in either a 20-foot or a 40-foot. Okay, so let's talk a little bit about levelized cost of energy. You know, we're talking about cost. I know there's a lot of lead acid replacements going on with everyone down in Haiti. So I want to kind of talk a little bit about the overall cost of the battery. Levelized cost of energy is something we always just use. You know, if we're looking at a battery that costs more up front than maybe say like a lead acid battery that might be very cheap up front but not last very long, it's important to look at the total cost of a kilowatt hour over the entire lifespan of the battery. So this is actually the equation we typically use. The price of the battery over the capacity of that battery. So let's say it was a 3.8 model. We would actually say 3.8 times the cycles warranted. This gets a bit confusing now when it comes to our new warranty, but you can really just say 10,000 at this point, depending on how you want to use the battery, times the efficiency and the depth of discharge. You can also add in things like ancillary costs. You know, if you know one battery requires a pallet jack or one does not, or things like that, those are all costs that can be added into this equation. This is an example of actually calculating this out. This is using a lithium competitor actually that had a lower upfront cost, but due to not warranting very many cycles, in their case, they actually came out at a higher cost. Kind of ignore this equation, it's a bit outdated, and then we were actually using 90% depth of discharge at the old warranty of 5,000 cycles. So now it is unlimited cycles, so you can plug in 10,000 even at 90%. Okay, though I do want to show you, so as far as that goes, I'm going to go ahead and click this and hopefully it doesn't. All right, Christian, I'm just going to confirm with you. Can you still see my screen here where we're at the levelized cost of energy calculator? You hear me, Christian? Oh.
I can see it.
Okay, sorry, Christian, we can't hear you too well. Okay, looks like somebody else. Okay, thank you, Sandra, for confirming. Looks like we're still good to go. All right, so this is our levelized cost of energy calculator built into our website, actually. Super helpful tool, especially if you're looking at comparing any type of batteries. So this is kind of going over the same math I just went through. This is where you can really kind of customize it. So say you are replacing a 48-volt battery, leading the lead acid with our 3.8. You can type in that right there. It'll give you all this stuff preloaded. You can type in, you know, what you're actually paying for that battery in USD. You can select the depth of discharge you're going to use. So let's say 80% for this case, which will give you a usable capacity. And then you can actually see what the levelized cost of energy is there. Now, if you were to, so if you're looking at doing something else as far as comparing it to a lead acid battery, you actually just want to go ahead and you can leave this the same and you can start typing in, maybe your lead acid battery is the 3.8 model. Let's just say it is a 3.8 and you want to type in various figures there. You can actually, okay, actually look at this. So we can compare to lead acid specifically instead of going through that whole rigmarole here. We can actually select flooded lead acid. You can type in again, let's say, you know, you're paying $1,000 for this battery. You can type in the voltage range. So maybe if you are using, let's say, 2-volt cells, and let's see, sorry, a little bit easier with a real example here, but then you can even type in your amp hour rating, your depth of discharge, let's say 50%, and even just by kind of messing around with these numbers, you know, saying 2-volt cells, things like that, you know, you can see here, this is probably pretty pricey. Let's say even if it was $200 a battery, you can see that the total cost using this calculator actually comes out higher. This is great to show to customers, where you can say, you know, this is what you're going to end up paying over the lifetime of this battery based on its cycle life versus the lithium iron phosphate SimpliPhi battery, where you can see it actually is lower. You can also click here, I'd like more information. This will allow you to type in your info and send something directly to us, where we can see that you filled this out and help you out with any, you know, further questions, or just if you need a little bit more information on what the LCOE actually calculated. So check out that tool when you have a chance, play around with it. It's really helpful. I can definitely help as far as showing customers cost comparisons. Okay, so I'm going to do a little bit about battery sizing here, and then I want to go into lead acid replacement. And then we'll finish up with just a very brief overview of installation. So I did mention, you know, we do offer 10-year warranty unlimited cycles now, but there is still a reason why you might want to use 80% depth of discharge over 100%, let's say. So let's say maybe it's a backup system. That would probably make a lot more sense to use 100%. You can use the entire battery's capacity. We really only need to discharge and charge every now and again in that kind of situation. If you're off-grid, or if you're replacing lead acids that are off-grid, 80% depth of discharge is going to make a lot more sense. You're going to maximize the battery's lifespan well beyond the 10-year period, and see a lot more capacity even after that 10-year period. So really, depending on your mode of operation, you can kind of adjust the depth of discharge accordingly. Probably one of our most important sizing requirements is that the battery should be sized to twice the inverter's output capability. The only time this is not the case is when using solar. So most inverters do not have a way to limit the output. So if we have an 8,000 watt inverter, we want to make sure that we have a minimum of 16,000 watt hours of batteries. So 8 kW inverter, 16 kilowatt hours of batteries. This ensures that there's no over discharge and fits into our C/2 guidelines. So if you have any questions on this, I know it's kind of a concept that tends to be asked around and some confusion around it. So please reach out to me after this, or go ahead and type in questions in the Q&A about this. But we really want to ensure that the battery bank does not over discharge. The Solarc actually has a limiter that you can type in and allow the battery not to be over discharged, but most inverters still don't have the ability to limit their output. Okay, I'm going to talk a lot about lead acid replacement. So let's hop right in. What are the key benefits of replacing a lead acid battery with a lithium iron phosphate SimpliPhi battery? You're going to get longer lifespan, obviously, a greater LCOE, as we just talked about and showed you on that calculator, higher power availability, definitely a lot smaller of a footprint to get higher power and higher energy demands without a large battery bank. No maintenance being one of the big ones here. No requirements as far as running outside and watering batteries or anything along those lines, as well as non-toxic. So you're going to see a lot less, if any, corrosion on the battery, and they're just going to end up lasting a lot longer and cleaner. So if you are doing a lead acid replacement, I'm just going to calculate this out for you. It's important to kind of know the math behind it. I'm going to show you another handy tool here in a second, but this is an example I built a long time ago. You can actually see here I'm using the 3.5 kilowatt hour model. This is an older battery that I used when calculating this out some time ago. So in this case, I knew that my new battery I wanted to replace the lead acid with was a 3.5 kilowatt hour 48 volt. I wanted to use 80% depth of discharge. So what I did here is actually calculate out what the usable capacity is at 80% depth of discharge. I got 2,800 watt hours. The current bank was a 450 amp hour 48 volt AGM. So we calculate out the total capacity there, 21,600 watt hours. Multiply that times the depth of discharge. So in this case, we're going to say 50%. I know that's even high for some lead acids, but just for this example, that's what I was using. Got 10,800 watt hours usable at 50% depth of discharge. Divide that by your new usable capacity per battery, the 2,800 watt hours, and I got a 3.8 batteries total. So round that up, 4 batteries would equal the same as this 450 amp hour 48 volt AGM bank. You can definitely take in efficiency as well if you'd like to. The Phi battery actually has 98% efficiency, so that's really not something you need to calculate too much. If you want to calculate out the efficiency of the lead acid, that can be helpful. Depth of discharge we did calculate out here. Heating and cooling losses might be important as well if you're in a hot area, knowing that the SimpliPhi battery basically sees 0 loss even at higher temperatures, whereas the lead acid you would expect definitely to see a lot of loss in a hot spot. Okay, so I want to show you 2 tools here. I'm going to pop out again of the presentation. We're trying to make everyone's life easier with these tools, really kind of make it, as simple as possible. So this is our battery bank sizing tool. It's a bit different than the lead acid replacement tool we're about to go over, but if you are building a new system from scratch and all you have is, let's say, the average daily consumption, let's say 15 kilowatt hours a day in this case, and we only want 1 day of backup, and we know it's a 48 volt system. It's as simple as that. This will calculate out all the amp hour ratings, and tell you exactly what the amp hour rating is of the battery bank, tell you the watt hours, various different things here, and just give you a simple 5 batteries, 5 3.8 48 volts to get this average consumption covered. Obviously you might want to just double check everything, of course, but again, you can hit I would like more information here on this page, and it'll actually send over to our SAEs, our sales application engineers, to look over this and give you a call and talk through the project. Okay, I want to show one more tool here that I think is even more helpful, and that would be the lead acid battery bank sizing tool. So I just kind of went through this math, but this actually does all this math for you. So let's just say we have, here. We could even just do like this, 48 volts. I know that's probably not realistic when it comes to lead acids, but let's just say, actually, why don't we say 24 volts. At, let's say 200 amp hours each. Your depth of discharge, let's say it was 40% in this case. That's what the customer was using. And then it calculates out for you exactly how many of these 3.8 48 volts would be needed to replace these 2 batteries at 24 volts. Let's assume they are put in series at 200 amp hour rating. And then you actually just are able to see exactly how many of these batteries you need to replace this one. So super helpful tool. Again, you can click more information here and it'll send it over to our SAEs. But definitely use those tools. If you have any issues using them, let me know. I'm recording this, as well as I'll send out the link or the slides after this presentation. You'll be able to see all these links. Kind of a nice little picture here I like to show. Here's the original lead acid bank on the left. Looks to be, like 24 batteries maybe here. A lot of corrosion, a lot of cables running all over the place. Looks to be in a battery box with a vent fan. Probably requires watering. It looks like they're flooded cells. And this is the actual bank to replace those. So you can see here, we cut down the size to almost a third, maybe even a fourth the size of the original battery bank. Cleaned up the wiring, not a lot of corrosion, and we can actually mount these batteries on the wall, making it a little cleaner. Okay, so I'm going to go very briefly into installation. This is really just a brief overview. If you're looking for some really in-depth installation, I'm running a workshop in about 2 weeks that's going to go really into design and installation. But just for this presentation, I just kind of keep it very brief. If you're looking for any documentation, like manual spec sheets or integration guides, you can find those on our website under product documentation. If you're receiving our batteries, this is what you would expect to see. They each come in their own individual box. Definitely check the battery for damage right away. Once it's left us, it's hard for us to do anything as far as shipping damage goes. So make sure to check it before you open the box or you sign for anything. Never a bad idea to check the breaker. If the battery's been dropped, the breaker not being able to hold down is a good indicator of that. And I say multimeter test, but really just keep an eye out, make sure that you got the battery you bought. So if it's a 24 volt, make sure it is a 24 volt and not a 48 volt by chance. As far as clearance requirements and mounting, we actually have virtually no clearance requirements. The batteries can sit flush up against each other. You don't want to stack the batteries on top of each other as far as weight goes. We do offer these brackets that you can see here on the right. These are designed for our batteries specifically to mount on the wall. That being said, you do not have to use those brackets. There's tons of options. You can use racks, battery boxes. I've seen people just throw them on shelving units. So as long as it can bear the weight of the battery, we're okay with it. As far as how they sit, if they're mounted on the wall, the only orientation requirement we do not cover is if the battery leads are pointed down. You might have seen it in a few other pictures, but that can push down on the power electronics, and over time, you might see a few issues with that. So they can sit on their sides though, they can sit upright, just don't have those battery terminals facing down. Okay, if you're looking at wiring, here's kind of a basic overview of how we would recommend, or how we require to, I should say, to wire our batteries. Unlike a lead acid where you're jumping from positive to positive to positive to positive up to some sort of connection point or bus bar, we actually require same length, same size cable, each battery running individually to either the connection point or to a bus bar. If you've got big systems, maybe something that's beyond just connecting to the inverter's bus or the inverter's connection point, you might require some things like a battery combiner box. Midnight Solar makes a great one. Outback does as well, and you can always build out custom designs as well. Again, this is really brief here as far as this installation goes, but if you want more information, sign up for that upcoming webinar in a couple of weeks here where we're going to do a full-on workshop of installation. As far as commissioning or programming the system, this is a good example of one of our integration guides. This is actually out of the Schneider integration guide. So basically, we're just trying to take the exact language that might be used in an inverter or a charger company, and we tell you exactly what the set point is. Always pull our integration guides straight from the website. If you don't pull them from the website, you might get an older version. So just make sure to pull them from the website and you'll be able to see these. Goes through things like absorb and bulk, what those voltages set points are. If you are using float, maybe on a charge controller, what that set point is, low battery cutout, high battery cutout, even goes into some more advanced functions like what the cell voltage should be set at or the automatic generator start trigger. These guides are really helpful, definitely a requirement, especially let's say if you're replacing a lead acid battery, you need to reprogram the system to fit in. So you're gonna wanna go through this integration guide and make sure everything's nice and programmed and ready to go. Okay, 2 more links and then we're gonna jump into Q&A. I just want to talk briefly about our new warranty registration. If you are installing our battery, go ahead and just fill out the warranty registration online now. Basically, it just goes through all the different, what the inverter is, what the inverter quantity is, your name, email address, phone number, all that fun information. This will actually automatically enter into our system and makes it a lot easier if there's any sort of troubleshooting you need to do later, or even if the customer just gives us a call so we can see exactly what that system is. So please, if you are installing these batteries, just go ahead and file the warranty under this document here. This can actually be found if you click support. Oh, sorry there. And it's right here where it says warranty registration. All right. And very last, I wanted to talk briefly about our IQ program. So this is our installer qualification program that I run. It's not a requirement to install our batteries. It's more of an added benefit of showcasing the installers we know that are installing our batteries. You actually need 2 SimpliPhi installations to meet this requirement. There's a test to take as well, and just make sure that you have the proper credentials to install batteries based on your local jurisdiction code. You get a nice little swag pack if you do fill out this and actually get certified, as well as probably the most important. Let me see if I can get here. If you do end up completing this program, you can end up on our where to buy page here. So if you can see our distributors are here, but if they're looking specifically for an installer, maybe if they're popping over here and they're looking for an installer, you actually see 10 Powers right here. But it's pretty open. If you look, I actually don't see any IQ installers in Haiti right now. So if you get on that list, then the customers will actually see you as somebody that's installed our batteries before and likely will call you if they're looking on this page. So really big benefit to kind of drive sales towards trusted installers. All right, let's pop open the Q&A. I see a couple questions. If you have any more questions, now would definitely be the time to go ahead and type them in. Okay, so what was the main factor for changing the life warranty rating of the battery? Good question. Really, it's just kind of falling into exactly, what we know is available for the 10-year period. We know that the battery can handle 100% depth of discharge at unlimited cycles in the 10-year period. Really, we want to leave that 10-year period as simple as possible while allowing basically, if you want to maximize battery life outside of that 10-year period, then you can always manipulate the depth of discharge. And what product is most suitable for commercial carport design, if applicable? Tough question. It's going to depend on a few things. Really the AC requirements. So if it's, 208 3-phase, probably the 48 volt battery. If it's just standard 12240, same thing, 48 volt. But if you're looking at something bigger with a 480 volt 3-phase AC requirement, then that's probably where you'd want to jump into that high voltage, just because the inverter that you'd be using wants to use that higher voltage. Awesome. Well, I don't see any other questions. So if there's no other questions, I just wanted to thank 10 Power, thank Christian again for hopping on. As I said, I recorded this, so I'll send everyone an email with the recording and the PowerPoint presentation.
Excellent. And I just want to add as well, thank you very much, everybody who was able to join. And thank you, Troy, for the very detailed and very good presentation that we had here. And we're definitely looking forward for more presentations. And then also everybody here that's in Haiti, please always reach out to us at 10 Power. We are here to continue assisting with these transitions.
Awesome. Thank you so much. I don't see any other questions. Sandra, good point. If anyone does need any questions answered in Creole or French, I'll give it a couple of minutes here if you just want to type those in, if you do have any questions that need to be answered in Creole or French. Just give a few minutes, make sure no one has any lingering questions. All right, looks like no questions. If you do have any questions though that do come up after the presentation, feel free to reach out to 10 Power or even reach out to myself as well. Thank you, everyone.
Thank you. Take care.
Thank you.